This is section 211, and we're going to take a look at lines. Today we're going to find the slope between 2 points, identify the different types of slope, and examine slope at rates of change. Although we have studied different types of slope for many years now, it's important to note that slope is ultimately just an expression of change. Slope represents the change in one variable, we call that the y, which is the dependent variable, as it corresponds to the x variable, which is the independent variable. Now, in an equation, we typically let slope represent the variable m. So let's look at a quick example here. Let's say that we are selling pies at lunch as a fundraiser for the Interact Club, and we determine that our profit in dollars can be represented by a line with the slope of 5/2. The slope of 5/2 would represent the change of 2.5 in profit for every one change in pie. In other words, I would get $2.50 in profit for every one pie that we sold. We could also say that we get $5 in profit for every 2 pies that we sell. Now, these are the different ways that we kind of represent our slope. So we can say slope is the change in the dependent variable divided by the change in the independent variable, or the vertical change divided by the horizontal change, or we'll see this more in like science classes. We get this delta y over delta x. That just means change in y over change in x, or rise over run. So given 2 points, the following formula allows us to find the slope. So this is the slope formula. Now I'm hoping that this is just review. And so if we look at this visually, if I wanted to then label it, we would say our first point is x1 and y1, our second point is x2 and y2, and I would just plug it into the formula. We have y2 minus y1 over x2 minus x1, and so I would get 2/3. And that's the same as rise 2 over run 3. So we're just going to kind of quickly go through this. The purpose of me showing these 4 examples are these are actually the 4 different representations of what the slope of between 2 points can look like. So we could take them and we can subtract them, y2 minus y1 over x2 minus x1, and we get a number. Like in this instance, it's 4. So 8/2 equals 4. Now I can do the same thing here. y2 minus y1, 4 minus 4, over x2 minus x1, 2 minus -11. 2 minus -11 gives me 13, so I get 0/13. 0 divided by 13 is 0. So I can get a slope of 0. Now notice we get a slope of 0 when your y1 and your y2 are the same. Now what happens when my x values are the same? What happens if my x1 and my x2 are the same? So if I were to subtract y2 minus y1 over x2 minus x1, I get a 0 in the denominator, which means it's undefined. Now what happens when they are the same point? You get 0/0, and that's actually a special case we call the indeterminate. Now we focus this a little bit more on pre-calc and calculus. So just know that it has meaning. The 0/0 actually has meaning. It's special. Now with those special slopes, okay, so we're going to focus on 2 of them. We're going to focus on what does it mean when we have a 0 slope and an undefined slope. We can kind of simplify it. If we know that our slope is 0, it's always going to be a horizontal line, and we can write it as y equals whatever the y value is. So in this instance, y equals 2 if my slope is 0. And if it's undefined, it's always going to be y equals whatever your x value is going to be. Now in the previous slide, I used that phrase, change in y over change in x, delta y over delta x. That's just the Greek letter delta. And it actually can be simplified to mean this. It's just a quick way of writing y2 minus y1, or in this instance, y1 minus y0. It's all the same thing. So let's look at a quick example here. Suppose that two separate temperature readings were taken at the ranger station on the top of Mount Sasquatch. At 6 a.m., the temperature was 24 degrees, and at 10 a.m., it was 32 degrees. So find the slope containing the 2 points. So y2 minus y1, so here's x1, here's y1, here's x2, here's y2. So y2 minus y1 over x2 minus x1, I get 8 over 4, which is 2. So that's my slope. Now, for the next part, it says interpret your answer to the first part in terms of temperature and time. So the 2, in terms of this idea of rate of change, means that, and I have to kind of rewrite this as 2 over 1 here, but what it's saying is that it's going to change by 2 degrees Fahrenheit for every 1 hour. And since the slope is positive, we know that this is going to be an increase of 2 degrees Fahrenheit per hour. Now predict the temperature at noon, so we can actually kind of sit there and count a little bit. So we know that at 10 a.m., or it starts at 10 a.m. and noon is going to be 2 hours later. Well, since it's going to increase by 2 degrees per hour, 2 hours, 2 and 2, that gives us 4. So we started at 10 a.m., 32, we add 4 at noon, and so that's going to be 36 degrees Fahrenheit. So what did we learn today? We talked about rates of change. We talked about slope. We found the slope. We looked at what slope means in a real-life example. And so how do I find the slope from 2 points? That's going to be y2 minus y1 over x2 minus x1. And then create an example that represents rate of change. You could do something as simple as selling a product. So I could say $100 per every 1 Game Boy sold. You guys are all too young for Game Boys, but back in the day, Game Boys were awesome. But this is my change in Y, and this would be my change in X. This does conclude our lesson. If you have any other questions, leave them in the comments.